Today we're going to talk about solving compound exponential and log equations. First, let's recall what a basic exponential equation looks like. It looks like 3 to the x equals 9, or e to the x equals 1. We're going to look at example 1, where 2 to the x minus 5 equals 8. A compound has something added or subtracted, multiplied, or divided to the x or to the base. So we're going to solve this by using our property that log base a of x equals y, if and only if x equals a to the y. And so we're going to switch this exponential into a log. So we're going to take our exponent, we have x minus 5, and it's going to equal our log of base 2, and it's going to be of 8. And now I'm going to convert this 8, because I know this 8 is 2 to the third. So we're going to have x minus 5 equals log base 2 of 2 to the third. And so these bases are going to cancel. We're going to get x minus 5 equals 3. And now we can just solve like a regular equation. So we got plus 5 on both sides. And we get x equals 8. Now we're going to look at example 2. We have 6 times 2 to the x plus 2 minus 10 equals 2. And we're going to do, first we want to get this base 2 by itself so that we can convert into our log. So we're going to add 10 to both sides. And we're going to get 6 times 2 to the x plus 2 equals 12. And then we're going to divide both sides by 6. We're going to get 2 to the x plus 2 equals 2. And now we want to convert into our log. We can do this by using our property, or we can take the log base 2 of both sides. And I'm going to show you how that works. So we're going to do log base 2 of 2 to the x plus 2 equals log base 2 of 2. And now we notice these bases cancel, and they actually cancel on both sides. And this 2 over here is just 2 to the 1 power. So these bases cancel, and we have x plus 2 equals 1. And so we're going to move this over here, x plus 2 equals 1, and we can solve this just like a regular equation. So we can subtract 2 from both sides, and we can get x equals negative 1. Okay, now I switched over to log. A basic log equation looks like we have log base 4 of x equals 2, or natural log of x equals 1 or 0. And so we have two examples here. Example 3, log base. But when it has no base, it's 10, remember? So we have 10 here. Log base 10 of x plus 6 equals 1. And so we're going to solve this by doing the same thing we did with the exponential. We're going to switch to an exponential instead of switching to a log. So we're going to use our property that log base a of x equals y, if and only if x equals a to the y. So we're going to take our inside, which is x plus 6, and we're going to set that equal to our base, 10 to the 1. And we know 10 to the 1 is just 10, so we have x plus 6 equals 10. And so we're going to subtract 6 from both sides, and we're going to get x equals 4. Now, one thing we need to check is if this fits in our domain. And we know that for a log, that everything inside the logarithm has to be greater than 0. So x plus 6 has to be greater than 0, so we're going to subtract 6 from both sides. We're going to get x has to be greater than negative 6. And 4 is greater than negative 6, so this one works. So we're going to have example 4. We have 2 log base 2 of x minus 5 equals 1. So this one's a little more complicated, has a lot more in there. So we need to get this log base 2 by itself. So we're going to add 5 to both sides. We're going to get log base 2 of x equals 6, and then we're going to divide both sides by 2. We're going to get log base 2 of x equals 3. And now we're going to switch into our exponential. So we're going to take our inside, which is x, and we're going to set it equal to our base, and it's going to be raised to the 3. And we know that x equals 8, because 2 times 3. 2 to the 3, 2 times 2 times 2 is 8. Now we want to check and make sure this is in our domain. We know everything inside the log, which is x, has to be greater than 0. So is 8 greater than 0? Yes. So our answer is x equals 8. And this is how you solve compound, exponential, and log equations.